The next question is from winter year 2022 and it's variant 3 paper 1 and it's question number 9. The question says that the first term of a geometric progression is 216 and the fourth term is 64. So we need to find the sum to infinity of the progression. So we have the geometric progression here, and for this geometric progression we have the first term, which is a 216, and we have the fourth term, which can also be given as AR cube, and this equals a 64. So we have to have the sum to infinity. Sum to infinity obviously is given by the formula a divided by 1 minus r. So it's just that we have the value of a, but the common ratio is missing. So to get the common ratio, I will be using the formula which says it's ar cube, which equals 64. T4 equals ar cube, or to write the term formula, I should say that it's Tn, which is equals to ar to power n minus 1. This is the general geometric progression and a term formula for nth term here. AR cube is equals to 64. We are talking about the fourth term. We know the value of A, which is a 216, R cube, which is a 64, or we can say it's R, which shall be equal to 64 divided by 216, and this whole shall be to the power 1 by 3 here. The cube root of 64 is a 4 and the cube root of 216 is a 6. So it's a 4 by 6 fraction, or I can say that my common ratio is going to be a 2 by 3 here. So this is going to be the common ratio that I should be having here. So after that, I need to have sum to infinity. My work is very simple now. I can say that the sum to infinity here is going to be sum to infinity, just substituting all the values. It should be equal to a, which is a 216, divided by 1 minus 2 by 3, or I can say it's a 216 divided by a 1 by 3, or I can say it's a 216 into a 3, and then this sum to infinity shall be equal to a 648 here. The second term of the geometric progression is equal to the second term of an arithmetic progression. So the second term, geometric progression, the second term of the geometric progression is equal to the second term of an arithmetic progression. So here we should know that for geometric progression, the nth term is given by the formula Tn equals ar to the power n minus 1. And arithmetic progression has the term formula, which is a plus n minus 1 times d. So general geometric progression, the general term, the second term here shall be equal to the second term of the arithmetic progression. So here I can say that this is going to be AR, and the A is of geometric progression, the first term, to the power 2 minus 1, which shall be equal to A plus n minus 1, which is a 1 in this case, and then it's going to be A plus D. The question here said that the first term of the geometric progression is a 216. So I should be using this 216 in this formula, and I can say that here it's a 216. I also have the common ratio, and the common ratio here was a 2 by 3. We already had the common ratio here, which was a 2 by 3. So I can substitute that 2 by 3 here also. So this is going to be 216 into 2 by 3, which shall be equal to A plus D for the arithmetic progression. So 216 times 2 by 3, that will give me a 72 times 2, and I can say here that A plus D shall be equal to 144. So this is the first equation that I have in terms of A and D for the arithmetic progression. The second statement here says that the third term of the geometric progression is equal to the fifth term of the arithmetic progression. So the third term of GP, for GP, it's going to be the third term of GP, geometric progression, shall be equal to the fifth term of arithmetic progression here. So again, for geometric progression, we know that by term formula, it is given as AR to the power 3 minus 1, which shall be equal to, and this is all for geometric progression, this shall be equal to A plus 5 minus 1, giving me a 4 times D. So here I can say that the first term for the arithmetic progression was given as 216 into 2 by 3 to the power square, and this shall be equal to A plus 4D. So this equals a 96, which is equals to A plus 4D. Or in other words, I can say this is A plus 4D, which is equals to 96 here. So A plus 4D equals 96. This is another equation that I have in terms of A and D. Let's solve the two equations, these two equations simultaneously. So if I solve the two equations simultaneously, I should be having here A plus D, which equals 144, and here it's A plus 4D, which equals a 96. Solving the two equations, the A gets simplified, and I can say it's a negative 3D, which equals 48, or D here then will be equal to a negative 16. So the common difference for the arithmetic progression is a negative 16. Therefore, I can say from this equation, which is A plus D, which equals 144, I can say it's A negative 16, which equals 144, or I can say it's the first term for the arithmetic progression, which shall be equal to 144 plus 16. So 144 plus 16, that shall give me the answer as 160. So this is going to be the first term for the geometric progression here. Sorry, for the arithmetic progression here. So we have the first term for arithmetic progression, which is arithmetic progression. We have the first term, which is 160, and we have the common difference, which is going to be a negative 16. The question actually has asked us for the sum of the first 21 terms. The question has asked us for the sum of the first 21 terms for the arithmetic progression. We know the formula for the sum. It's going to be Sn, which equals n by 2 times 2a plus n minus 1 times d, or sum of the first 21 terms, that shall be equal to 21 divided by 2 times 2 into a. We have the a value, which is 160, and d value, which is a negative 16. So 2 times 160 plus 20 times negative 16, 20 times negative 16 here, or we can say it's S of 21, which is equals to 21 by 2 times 320, negative 320. This becomes a 0, or I can say now that the sum of the first 21 terms is going to be a 0. So the sum of the first 21 terms is going to be a 0. This is going to be the answer. And this is possible because some of the terms might be positive, some of the terms might be negative. So they ended up giving the sum as a 0 here. So this is how this question needs to be done. The next question is from summer 2018, and this is paper 1 variant 1 and question number 8. Summer 18, paper 1 variant 1, question 8, and they are saying it's a geometric progression which has the second term of 12 and a sum to infinity of 54. So find the possible values of the first term of the progression. So just be particular about the word which says values of the first term. Let's start working on it. It's a geometric progression where the second term is equals to 12 and the sum to infinity is equals to 54. We need to find the possible values of the first term of the progression. Second term, the second term of the geometric progression by Tn formula, which is equals to ar to the power n minus 1. So the second term here, T2 here, shall be equal to ar to the power 2 minus 1, or I can say that the second term here is going to be ar. The second term is a 12, so it's 12 which is equals to ar, or here I can say that my a value or my r value is going to be a 12 by a. So this is the first equation for r in terms of a that we have in this question. The second information that we have is regarding sum to infinity. The sum to infinity is given as a divided by 1 minus r, or I can say it's a 54 which is equals to a divided by 1 minus, let's substitute this r over here, which is a 12 by a, or I can say it's a 54 which is equals to a divided by, now if I take the LCM, then this becomes a minus 12 divided by a here, or I can say it's 54 which is equal to a into a divided by a minus 12, or I can say it's 54 times a minus 12 which is equals to a square, or 54a minus 54 times 12, that gives me a negative 648 which equals to a square. Rearranging them, I shall be getting a square minus 54a and a positive 648 which shall be equal to 0. Solving the quadratic equation, I'm getting two values of a. One is a 36 and the other here is going to be an 18. So this is why they were saying they were asking us to find the values of the first term of the progression. So the values of the first term of the progression, these two are going to be the values of the first term of the progression for this question here. So just be particular about the words also. If they are saying values, then that means there should be more than two values for this question here. Let's do part. The B part says that nth term of a progression is p plus qn. And we are supposed to find out the sum of this progression over here, the nth sum of this progression here. So if Tn equals p plus Qn, then I can say that when my n is a 1 for the first term, then the first term a shall be equal to a p plus q times 1, which shall be equal to just a p plus q. So I can have the first term in terms of p and q as a p plus q. In the same way, I can say that when my n is a 2, the second term here shall be equal to p plus 2q. So this is the first term, this is the, and we have the first term as p plus q, and we have the second term as p plus tq. That means our common difference can be given as T2 minus the first term, which is A, or I can say it's P plus 2Q, which shall be negative P plus Q here. Or I can say that the common difference here is P plus 2Q minus P and a minus Q. And here I will be able to get my common difference in terms of q, which is just going to be a q value here. They are asking for the sum. So if they are asking for the sum in terms of p, q and n, then we know that I have the first term in terms of p and q, which is a p plus q here. I have the common difference, which is again in terms of q, and I can apply the sum formula, and the sum formula here is going to be Sn, which is equals to n by 2 times 2a plus n minus 1 times q times d, which in this case is a q. So Sn here is going to be n by 2 times 2 times a, which we have as a p plus q, plus n minus 1 times d, and in this case the d is a q value. So simplifying this equation, I should say it's an n by 2 times 2p plus 2q plus qn and a minus q, or I can say that the sum formula here shall be n by 2 times 2p plus q and a plus qn. So this can be my expression for the nth sum in terms of n, p and q. So this is going to be the answer here. Now the second part of the question says, given that S of 4 equals a 40, S of 4 meaning sum of the first 4 terms equals 40 and sum of the first 6 terms equals 72, S of 6 equals 72, we need to find the values of P and Q. In the previous part, we find Sn, the sum formula in terms of P and Q, and this was n by 2 times 2p plus q plus nq. Now, if sum of 4 equals a 40, let's start taking in the data. Sum of 4 equals 40, then I know here that my n equals a 4. So substituting n as 4 in the sum formula that we have just formed in terms of P and Q, I should say that 40 shall be equal to a 4 by 2 times 2p plus q plus 4q. Or I can say that this shall be equal to 40 divided by 2, which will give me a 20, which is equals to 2p plus 5q. So I am having here 20, which equals 2p plus 5q, and this is going to be my equation 1. Second equation can be obtained with respect to S of 6, which equals 72. So S of 6 equals 72, and in this case my n value here is a 6. Therefore 72 shall be equal to 6 divided by 2 times 2p plus q plus 6q, or I can solve it and I can say it's 6 and 2 solved as a 3, and then 72 divided by 3, that will give me a 24, and this then shall be equal to 2p plus 7q. So this is then going to be the second equation. I can solve the two equations simultaneously to get the value of p and q. So solving the two equations simultaneously, I will go for elimination method, and here I can say it's 20, which is equals to 2p plus 5q. This is equation 1, and second equation shall be 24, which is equals to 2p plus 7q. So solving by elimination method, I should be changing the sign so that I can eliminate 2 here, 2p here. So I will be having here 20 minus 24, giving me a negative 4. 2p minus 2p becomes a 0, and 5q minus 7q, that will give me a negative 2q. The negative gets simplified, and here I can say that my q value shall be a 2. So this is going to be the answer for 2, the value of q, which is equals to a 2, and then substituting this value in any of the two equations that I have, I can say here that if I just go for equation 1, then I can say that it's 20, which is equals to 2p plus 5q, or I can say it's 20, which is equals to 2p plus 5 times 2, or it's going to be 20 minus 5 times 2, which is a 10, which is equals to 2p, or it's going to be a 10, which is equals to 2p, or solving it further, I can say that the p value shall be equal to a 5. So the question was asking for the values of P and Q. We have just gotten the value of P and Q. My Q is a 2 and my P is going to be a 5. So this will give me the final answer for P equals 5 and Q shall be equal to a 2. So this is going to be the solution for the last part of this question. The next question is from May-June 2017, paper 1, variant 3, and this is question number 2. So the common ratio of a geometric progression is r, and the first term of the progression is given as, it's the first term, which is given as r square minus 3r plus 2, and the sum to infinity is s. So we have to show that s equals 2 minus r. So solving it, I should be knowing that sum to infinity is equals to a divided by 1 minus r. Sum to infinity shall be given as s, and the first term is given as r square minus 3r plus 2, which should be divided by 1 minus r. So solving r square minus 3r plus 2, I should know that this can be given as a negative r and a negative 2r and a plus 2. Or solving it further, I can say this is r minus 1, negative 2 common, and this is also going to be r minus 1. So it's going to be r minus 2 and r minus 1. So r squared minus 3r plus 2 can be written as r minus 2 and r minus 1 here. So I can substitute this value for s, and I can say that it's r square minus 3r plus 2, which can be written as r minus 2 and r minus 1 divided by 1 minus r. So just by changing the sign of r minus 1 by taking negative common, I can say that this can be written as a 1 minus r times r minus 2, which shall be divided by 1 minus r here. So 1 minus r gets simplified, and I will be left here with negative r minus 2, or I can say that s then shall be equal to a 2 minus r. So this is what we had to show, and we have obtained s, which is equals to 2 minus r. So this is shown. Second part of the question says find the set of possible values that s can take. Possible values that s can take, we are talking about sum to infinity here. And for sum to infinity, we know that the common ratio has the condition for negative 1, which is less than r, and this should be less than positive 1 here. So now as for sum to infinity, we know that it is in terms of r, which is 2 minus r. So just multiplying everything with negative r, I will be getting 1 less than negative r, which is less than a negative 1, and then balancing it with 2, I should say it's a 1 plus 2, which is less than 2 minus r, that is less than negative 1 and a plus 2. So here I will be saying that it's 2 plus 1, 3, less than 2 minus r, which is sum to infinity, that should be less than a 1. Or in other words, I can say that it's 1 less than 2 minus r, which is less than a 3. Or for set of possible values that s can take, I can say it's 1 less than s, which should be less than 3 here. So this is going to be the answer for the set of values of sum to infinity, set of the possible values of sum to infinity that can be possible here. So this is the end of the topic. We have practiced quite a lot of questions, and I hope now that the topic is clear to everyone, and you shall be practicing more from past papers with respect to this topic. And best of wishes to everyone, and Allah Hafiz.